So our next thing to look at is how we express concentrations when it comes to solutions. Concentration is a way that we express the amount of solute that is dissolved in a solvent. Now, there are a number of different units that we use to express concentration, and most of those we'll get to in general chemistry too. But the one that we use more often than any other, that's more important than any other, is we abbreviate with capital M, but it stands for molarity. And molarity is equal to the moles of solute divided by, and this is where we have to be really careful, the liters of, not the solvent, but the liters of the solution. So if we're talking about making a 250 milliliter solution of something, that does not mean we're using 250 milliliters of water or whatever our solvent is. It means we need a total of 250 milliliters of solution after our solute has dissolved. So when we're doing this, we usually use a special piece of glassware. And that's what we've pictured here. This is known as a volumetric flask. And volumetric flasks have only a single measurement on it. You can see in this picture, there's just this one line right here. And so whatever volume that volumetric flask is, they come in standard sizes. That's the only volume you can use to measure. But you know that if you filled it to that line, that your measurement is going to be extremely accurate. That measurement is a lot more accurate than a graduated cylinder or an Erlenmeyer flask or a beaker. So if you need to do this, you measure out your solute, you add it to the flask, and then you add solvent, up to near that line. You mix it really, really thoroughly until all of the solute has dissolved, and then you can fill it exactly up to that line. And then you can be confident that your liters of solution are accurate. So let's just do a couple of practice questions here. So we're going to calculate the molarity of a 250 milliliter solution containing 4.498 grams of potassium bromide. So our molarity will be the moles of solute, which in this case means the moles of KBr, over the liters of solution. And here we're told we have a 250 milliliters. We would convert that to liters, 0.02500 liters. And then we need to do our calculation of moles of KBr. 4.498 grams of KBr times 1 mole over 119 grams is 0.03780 moles. So we can now put that into our molarity equation and find that this solution is 0.1512 molar. All right, let's do another one. Now we're going to say 5 grams sodium chloride is used to make 250 mils of solution. And again, we want to calculate the molarity. So our molarity equation is going to look the same as it did in the previous problem. We're going to convert our milliliters into liters. And then we need to convert our grams of sodium chloride, 5.00 grams NaCl, 1 mole of sodium chloride is 58.44 grams, or 0.0856 moles. We put that down here. And we get our concentration of 0.342 molar. Notice we kept this one to 3 significant figures because our volume was given in 4 significant figures, but our mass of our solute was only 3, which meant we had 3 sig figs in moles, leaving us with a concentration of 3 sig figs. We can also use this formula to calculate if we wanted to dilute a solution. So for example, you may have used hydrochloric acid in the lab at this point, and if you have, you probably used it as a concentration of 1 molar or somewhere in that range. But typically we don't buy hydrochloric acid as a 1 molar solution. Hydrochloric acid is often sold as a 12 molar solution. Now let's say what we actually need is 1 liter of a 1 molar solution. How are we going to get that? Well, what we need to assume or determine how many moles of hydrochloric acid do we need. So if we know that molarity is equal to moles over liters, then we can rearrange this equation to say that moles of solute is equal to the molarity of the solution times the liters of the solution. So in this case, because what we need is 1 liter of a 1 molar solution, we can plug these in. And we can see that what we need is 1 mole of HCl. So in other words, what we actually need is to get 1 mole from that 12 molar solution. How do we do that? Well, we can use this same equation, moles of solute is molarity times liters, except at this point we know the moles we need, that's what we just found, and we know the molarity, that's given as 12, so we need liters. So liters equals moles over molarity. So the number of moles we need, 1.0 moles, over the molarity, 12 molar, equals 0.083 liters. So in other words, what's happening here? This 0.083 liters, which would convert to 83 milliliters, 83 milliliters of the 12 molar solution contains the same number of moles as 1 liter of a 1 molar solution. And so by considering that, all we have to do now is we can take 83 milliliters of the 12 molar solution. Now we have all of the moles that we already need, and then add enough water to make that solution now no longer 83 milliliters, but 1 liter. Now you can always solve it in this way, but we can simplify everything we just said for dilutions into the following equation. M1 V1 equals M2 V2. And that's because we're keeping the same number of moles during the dilution. We're just changing the volume so that we can influence how concentrated the solution is.